I am Abhishek and I would be teaching you physics today. So, you would be starting a fresh topic today. Motion in a straight line, right? Is it okay or not? Are you not really clear of about the topics? Don't you have the schedule? You don't have the schedule? Okay. And the previous topic, which was errors, was it finished or not? It was finished. So that means, sequentially, this is the next thing that should be coming, right? So, I have three problems here which less than 20% of you were able to solve. Okay. So these are a little difficult. I mean, like the statistics say this. I don't think that they are difficult. It is just that you have missed some point here or and there, and that's why you didn't attempt them. So this is assessment 2, right? Assessment 2, question 3. I'll discuss first. Now, the assessment 2, question 3, it says length and breadth of a rectangular plate. Length is 15.30 plus minus 0.05. Breadth is 12.80 plus minus 0.05. Okay. You need to find the area along with the uncertainty. Okay. Uncertainty is this thing, the error actually. So this is centimeter, this is centimeter. All of it has same units. Okay. So if you do remember that area was length into breadth, you can multiply it 15.30 into 12.80. Okay. Don't worry, I'm not gonna find it. You would have to do it on your own. Now, the area, since it is a product, do you remember that actually you cannot calculate the absolute error in this scenario? You cannot calculate. Absolute error can be found in these scenarios only. Okay. When two quantities are added, the absolute error becomes delta A plus minus delta B, both plus minus actually, and when they are subtracted, even then the absolute error becomes delta A plus minus delta B, here also plus minus. Okay. The absolute errors are added. While for all other cases, multiplication, division, power, you need to add relative errors. So the relative error is this delta L by L plus delta B by B. Is it okay? So delta A we don't know. Area would be a product of these two quantities. So whatever it is, LB. Okay. Now this thing would be delta L is 0.05 upon L plus 0.05 upon B. Okay. You can take LCM, it would become B into this thing plus L into this thing upon LB. So that LB cancels on both the sides. So the absolute error would be how much? It would be the breadth was 12.8 into 0.05 plus 15.3 into 0.05. You can take 0.05 common and the two quantities get added. It becomes 28.1 into 0.05. Okay. That would be the absolute error. Okay. You can take 28 as the approximate value. Okay. So solving it, the error becomes, if you know how to deal with the fractions, some of us would actually do this thing is 5 by 100, then cut it out and so on. Straight away take it as 1 by 20. Just remember the fractions, right? It's not that difficult. Straight away remember the fractions. So it would be 1 by 20, and I can see that the whole quantity becomes 28.1 upon 20. It would be more than 1. Only one option has error more than 1. So I never needed to calculate this I just chose the option on the basis of this only. The option D had 1.4%. Okay, that's the trick of doing questions, objective questions in an exam. You need not do the difficult calculation part. You know, the only thing that I saw in the question, out of 4 options, the second and third option were something like 196.0, 196.0 plus minus 0.7 plus minus 0.07. Okay, very tiny difference in these two values, and these two are same. For option 1 it is 195.8, 195.8 plus minus 0.7. This is 195.84 plus minus something else. You know, these values are very close. You cannot use approximation, which means in reality you shouldn't be using these values. You shouldn't be calculating them. That's the logic of solving objective type questions. You know, in JE, be it mains or advanced, they never ask you to do difficult calculations. This is a pretty difficult calculation. Okay, this is a pretty difficult calculation. So you need not solve things. Actually, there would be some way around while you are solving the question. I found the way around. I didn't knew it actually. This was not a question which I had seen earlier. But while solving it, I understood, oh, there is a logic behind it, that actually these 4 values are really similar. Okay, they are really close, which means actually the answer should not be found using these values. It should be found using the other value, which is this. This was 1.4%. Okay, getting my point? So the other one, the next one, a new system of units is chosen such that it is question 10, assessment 2, question 10. Previous one was assessment 2, question 3. Okay, unit of mass is U. So for m we take U kg. Okay, unit of length is V meter. Okay, V meter, and unit of time is W seconds. The unit of 1 Newton in the new unit system is, so you know 1 Newton is what? 1 kg meter per second square. Just a second, and this happens all the time. Yeah, sorry please. Now in this question, you know how to this is the you know spread of 1 Newton. Okay, if you split it into the individual standard quantities, this is the formula. Now here you need 1 kg in the new system. Let's call it 1 m. The new unit is 1 m, which is actually equal to U kg, which means 1 kg, the older unit, is actually equal to 1 by U m. Okay, 1 by U m. Okay, getting my point? You got my point? I said let the new system of mass, the new unit of mass be m, capital M, or something. You can call it you know apple, you can call it whatever the name you like. Okay, so this is 1 m, the new mass, the new unit of mass. So the older unit in terms of newer unit is this, which means the older unit in terms of newer unit for length would be this. If 1L is the new unit, 1L is the new unit, it is equal to V meter of the older unit, and 1 capital T is the new unit, which is equal to 1 W seconds of older unit. So 1 second will then become 1 by W T. Now start replacing. So this thing would be 1 kg is 1 by U, 1 meter is 1 by V, 1 second is 1 by W raised to power minus 2. Okay. Okay. So this would be 1 by UV W square. The answer is C U minus 1 V minus 1 W2 new unit. Okay, the new unit would be there, M here would L here and T here would be present always. Just separate them out and they would become M L T minus 2. This is the name new unit. Okay, getting my point? Okay, getting my point? Instead of struggling with question, what you need to do, get the older unit in terms of newer unit. Okay, just replace, the answer is done. I hope no one has a doubt in it here or online. Somebody is asking a question. I was expecting it. Please explain, also explain 4 question. I don't have 4th question. If you could just ask. Okay, it would come during the course of class. So I'll discuss that one as well. Now the assessment question 4, assessment 2 question 4. Here is the duster. Okay. Now one thing that I would like you all to do is attempt these questions at home. Don't copy them here. Okay. What people do is they copy their problems. Okay. In all these classes, what they do, I solve a question for them. They copy that. Okay, ho gaya, bas, that's done. It's not done. It's never done till the time you solve it on your own. Is it okay? Till only at that point of time you would understand whether you understood it while in the class or not. So if you are copying it, copy it just for your record. Please solve it at home. So it is the question 12th. Now 12th question. A student performs an experiment to determine the Young's modulus of wire. So what is this Young's modulus? Anyone? Stress upon strain. So you have mugged up the formulas. Great. See, actually this Young's modulus, this is a quantity that you would study in the later half of 11th. Okay. In second book it is the first chapter, properties of solids. Okay. So in your school courses I think you must have reached till that point. Somewhere gravitation or properties of solids must be running, okay, in most of the schools. So that's why, you know, in the chapter of dimensions and units, the quantities that we discuss are only those quantities which are actually used in whole of 11th and whole of 12th. So it is just that even if you don't remember the dimensions or units of a particular quantity, don't worry, you would actually be able to understand and remember it in some course of time. Okay. So the question says, a student performs an experiment to determine the Young's modulus of wire exactly 2 meter long. So if I am right, Young's modulus hota tha stress by strain. It was stress by strain. Stress was actually a type of force upon area. So almost all of you are able to recall it. Strain is change in length upon original length. Dimensionless. Okay. So change in length is delta L upon L, dimensionless quantity. Okay. Now length is given as 2 meter. In a particular reading, the student measures the extension in length of wire as 0.8 mm. Delta L is 0.8 mm with uncertainty of this. Okay, 0.05 mm. Okay, uncertainty of this. Uncertainty means error. Okay. The length is known to be exactly 2 meter, which means there is no error in this measurement. Okay. At a load of exactly 1 kg. So the force is how much? 1 kg means how much? 9.8 Newton. The question says that the load is 1 kg exactly, so no error in there, in it as well, okay, no error in the quantity. The student also measures the diameter of wire to be 0.4 mm. Diameter is 0.4 mm plus minus 0.01 mm is the error. The Young's modulus obtained from the readings is, okay. So now let's try to find force. This would multiply, and this is A delta L. Is it okay? Okay. The value would be, force is 9.8, L is 2 meters, A is pi d square by 4. Is it okay? Pi d square by 4. So it would be pi d is 0.4 mm है, so 10 to the power minus 3 whole square by 4 into delta L is 0.8 mm, so into 0.8 into 10 to the power minus 3. This would be the exact value of Young's modulus. Okay, now let's try to find the error. So delta y by y is how much? Since there is no error in F, no error in L, I will not write these two quantities in the equation. Is it okay? I will use a different symbol for delta here, because in errors also we use a delta again. Is it okay? In errors also we use a delta triangle. So if I use two triangles, it becomes a really confusing thing. Okay. So the Young's modulus, the error in Young's modulus would be, the first term delta f by f is 0 because there is no error in f, so delta f is 0. Second term delta L by L is again 0, no error in L. Third term would become delta A by A, and the fourth term would become delta this upon this, delta L, whatever you may call it. Is it okay? Now area again is how much? Pi d square by 4. So if I want to find error in area, what I would do? 2 delta d by d. No need to include pi and 4. They are constants, so they never have any error. What people do, they still keep pi by 4 here. They still multiply things here, which is wrong. This is the error equation, and in it only those quantities should be there which have an error. So since pi and 4 would have no error, no place for pi and 4. Is it okay? So error in A would be how much? 2 delta d by d plus delta L by L by delta L. Now let's find 2. This thing would be 0.01 by 0.4 plus length. In length the error is this upon 0.8. This is delta y by y. Okay. So the value would be how much? This is 2 and this would be 0.005 plus 5 upon 8, and it would be 5 upon 0.625. So 0.0625. Okay. So the relative error is how much? You can add 0.675, 0.675. Okay. Now the problem is, none of the question has this value. Why? The question expresses value in this form. It uses absolute error. The options are given in this form. The value plus minus absolute error. That means we need to multiply y here. Now there is a problem. I don't have y. I didn't multiply it. I didn't solve it. Now how to go for it? All four options. Look at the options. All four options have the value of y as 2.0 into 10 to the power 11. All four options. So we actually never needed to solve this, and this is the thing that you need to understand, you need to remember always. Always keep the final calculations for the last step. Why? The reason for that is that there may be a case in which these calculations would already be, done somewhere. The question would not need them. So I already know the value of y, 2 into 10 to the power 11. So I'll just multiply it. Okay, getting my point? Getting my point? So if you could just multiply, how much would be the value? Hmm? 0. Exactly. Somewhere, 0.13. In fact, yeah, 0.13 something. But the question is expressing error till the first decimal place, till this point. So no need for 3 and all. Is it okay? So the option is C, because in C option the value is 2.0 plus minus 0.1 into 10 to the power 11. That's it. Is it okay? You never needed to calculate the real value. So let's start with the actual thing which we planned to study today. Now, somebody asked a question. Please explain question 10 and 12. Should I? They are in the sheet. So do I need to revisit again? Somebody is asking whether I should solve question 10 or 12. I already did, and there is no different way of solving it. So just go through the same portion if there is any confusion. Okay, just go through the same portion. Let's continue. Now let's start. The topic that we'll start today is motion in a straight line. Okay, now since you have already studied a lot of this in your classroom, okay, you would have studied a lot of this in your classroom. I would be running through those trivial things which you already know. You have studied this in 9th, you have studied this in 11th as well in your school. Okay, I don't have question number 9 in the sheet actually. So okay, during course of the lecture I'll get question number 9th in the printed form. Okay, printed form. 4th was also there. Okay, no 4th. Okay, somebody has. So if you could just open the question window. Somebody asked question 4th and question 9th. 4th, and this is identical. It says energy. Now motion will find place in some other time. Energy E, C, energy E, velocity of light C, and force F are chosen as fundamental units. Which of the following would be dimension of time? These are fundamental. Okay, these are the fundamental units. So you need to find time in terms of these. Okay, you need to find time in terms of these. Now this is not a very easy thing now. Okay, let's discuss how to approach. See, energy, if I write, it has what dimensions? M, L2, T minus 2. C has dimensions L, T minus 1, and force has dimensions M, Okay. Now, how to approach this kind of problems? How to approach this kind of problems? Any idea? See, you have all these dimensions. You need only t. Getting my point? On the right hand side, you need only t. So you need to combine these quantities in such a manner that only t remains. Is it okay? You have to combine these quantities in such a manner that only t remains. So let's see if I could use these two. Okay, they are solved on a little bit trial basis. Okay, trial and error. So if I take E by F, M cancels, one of the L cancels, but the problem is T also cancels. Oh, is it okay? Okay, but let's see. You get only L. Since for L you have this quantity, can we replace it here? C is what? L t minus 1, which is E by F into t minus 1. Bas, you got the answer. Just put t on the left side. It is what? 1 by t. Take t there and bring c down. So it would be E by F C. Question 8 from assessment. Question 2. अरे सारे सॉल्व कराओगे क्या यार? The class would go in this only. Okay. See, I'll just give a hint. Okay. The second question is perfectly identical to the question which we did in the area wala. Okay. दो lenses हैं, two lenses are there. They have some focal length, and you need to find the combined. One second. Combined. What will be percentage error of a combined lens? I don't get it. There is some language issue as well. There should be percentage error in the focal length of combined lens. Okay, focal length of combined lens. So if you remember, power was sum of this. The net focal length would be like this, right? And how to approach this? There is a question in NCERT in which the resistances are added in inverse order. Approach like that. Differentiate it, so you get this minus sign. If you differentiate this, you get this with a minus sign, and if you differentiate this, you get this with a minus sign. Okay, though all those minus signs, they cancel. This is the small error in F, this is the small error in F1, this is the small error in F2. Is it okay? You can replace the values. If you know F, you can find it from the original formula. You can find F. If you know F, you can put it here, you can find the error, absolute error, then the percentage error. Is it okay? Somebody said question 8. This is the last I would be discussing. Now somebody is asking the dimensions of L by R C V. I'm not discussing this. This is a straightforward question. Just find the dimensions of R, C and V from NCERT and what? Is it okay? Okay, I won't be discussing it. See, there is some basic logic behind all the doubts. There should be some logic behind the doubts. The doubts should not be really straightforward. It means if somebody is asking this doubt, they should actually revisit the paper. That's it. Okay. Now somebody from here gave the paper. One more thing. Now since this is the beginning of session for you, for your seniors, I started taking classes from, let's say, 2-3 topics down the line, actually 2-3 chapters down the line. So you have all the time, and I am giving you that important tip. For every assessment that you write here, be it physics, chemistry or maths, for every assessment that you write here, you need to devote twice the time at home analyzing it. Is it okay? So if you write assessment here for 1 hour, you need 2 hours to analyze it. Now, what is all that you need to analyze? Very important question. You need to analyze, first of all, you find the concepts in which you are weak. Find the weak concepts, go through them, study hard, solve those questions which you missed. Okay, first point covered. Second point, you need to find what? The questions you lost because of calculation mistake, error in marking. Okay, there would be, if you write it down, there would be some 8 or 9 type of errors which a student can commit. Okay, guesswork would be one type of error. Guesswork rewards also. At times you get positive marks for guesswork, but at times you make it negative as well. So use guesswork carefully. Okay. Okay. So write those 9 type of errors. Okay. Error. Okay. And you need to for every question, for every wrong question, you need to fill on a sheet. Type 1 mistake you did, type 2 mistake you did, type 3 mistake you did. This kind of analysis sheet should be there. A table. Question 1, type of error made. If it is correct, then correct. If you are trying, if you are writing error, if it was wrong, then what type of error? For question 1, let's say you made a calculation mistake. Let's say you made this. So out of all the type of errors, most of them are avoidable. Please try to make this kind of sheet. Since it is start of session, you will get all the time to correct it. Okay, but don't push it to the next year. By the time you will reach in 12th, you would already be feeling the pressure of boards. Is it okay? Okay, so 11th is the right time for this. Make an analysis sheet of this kind for every assessment you do, and that's why it would need 2 hours for every 1 hour of test. At the end, add positive marks for whatever mistakes you made. For example, can I have a little silence, please? For example, let's say your first question was wrong. You scored -1 for it. You knew the answer. Okay, you knew the process, but you made some mistake. So actually you lost 4 marks plus 3 marks which you could have gained, and -1 also. So add +4 here. At the end, write projected score. You would be shocked to see the result that actually out of 100 marks you are getting 30 and you are losing 40. You are losing more than what you actually got. You should be scoring 70. You would be shocked. And if this projected score starts matching with your actual score, that means you have corrected all your mistakes. Okay, that means there is a flaw in concepts now. You need to work on concepts. So for most of the students, marks scored are always less than the marks lost. Exactly. So let's start. This is something which I personally ask my students to follow. Okay, in fact I have made an Excel sheet for this. Now let's start. Motion in a straight line. Since I said earlier, as I said, that I would be discussing only those topics which need a little elaboration, otherwise I would be running. For example, I won't be discussing 3 equations of motion using calculus. Okay, you already know it, but I would be discussing how to use them, right? We would be discussing questions. So motion in a straight line, you already know that this is a straight line. If a particle goes in this direction, or if it comes back as well, okay, this is called a straight line motion. It is also called rectilinear motion, and also called motion in 1D, 1 dimension. Only x is changing. Then I have this question. Let's say a particle is going in this direction. Both x and y are changing. Is it motion in 1D or 2D? No, it is in 1D. I cleverly concealed a fact. That actually only 1 dimension changes independently. Getting my point? If you have studied straight line, you would know that on a straight line, if x changes, y also changes. Y is dependent on x. Okay, so only x is changing. Okay, with respect to time. Y is changing because X is changing. So only one independent change is happening. That's why it's a straight line motion, a 1D motion. If the motion is of this kind or some other curve form, what happens? 2D motion. Why? Because both the values are not changing according to the same sequence. Okay, here also if X doubles, Y doubles and so on, same sequence. Not here, not here. Is it okay? So let's start. Now, before I proceed any further, I would discuss reference frame. Do you remember what is a reference frame? What? Exactly, exactly. To us, a reference means not a point. To our simplified sense, I would like to teach you simplified physics instead of heavy, language-based physics. So they say a reference frame or reference point. Okay, it is a point from which all the observations are made. I say that reference point is something at which I would place one guy and he would inform me, okay, bhai sahab aisa ho raha hai, okay, bhai sahab aisa ho raha hai. That is it. I would need a, not a clever guy, a straightforward guy who explains me everything what he sees. Just that. So to us, reference frame is any guy who is decently educated. That's it. Okay. Okay. Now let's see what quantities of motion. Okay. Parameters basically. What motion parameters we have. First, distance displacement. Okay, I think it is okay. It is all really clear with you all. Okay, distance is what? Axial path length. Displacement is the shortest distance. So when I say distance, this is the path. When I say distance, it means the actual path length measured, and displacement is something like this. Now displacement is a vector quantity which is always directed from initial position to final position. So distance slash displacement is the first parameter. I am using slash because it depends on which way you want to see. You want to see the actual path or the shortest possible path, right? Now the next one, I will be raising it. Additionally, there was one thing called position. What happens if I clearly mention a coordinate axis with origin? Position vector is what? This, a vector joining any point, a vector joining origin to any point P. So if the P point has x and y coordinates, this vector would have x I cap plus y j cap, these coordinates. Okay, so why discuss position? Now this thing, let's say this is the initial point, this has r1 position vector, this is the actual path is this is the final point and the position vector is r2, this is the displacement vector s vector. Is it okay? So if you see r1 and s are in order, do you remember when two vectors are in order, we say that the third vector which joins the tail of first to the head of second is the resultant, right? So from here we can see that r2 vector resultant of r1 s. So s vector is what? r2 vector minus r1 vector, which is what? Delta r. So displacement is what? Is equal to change in position vector, right? Is it okay? Okay, so we use them interchangeably. We use position and displacement interchangeably because their change is the same thing. In case of position, there is one problem that you need to know the initial position. Okay, if that's given, go ahead, same thing. I'll erase it, it's not much of a concept actually. The second one would be speed slash velocity. Okay, speed is what? Rate of covering distance, or rate of change of distance, you can call whatever you like. This is what? Rate of change of displacement. Okay, now you know that there are two types, instantaneous and average, right? First let's discuss average. Speed is what? Total distance upon total time. You already knew this when you passed ninth. Is it okay? What about average velocity? Now let's check it diagrammatically. These are 2 points. This is the actual path. This is the actual path. So total displacement is this. Okay, so it would be, if this is delta s, it would be, let's call it net displacement by total time. The direction of average velocity would be along what? Displacement. Okay, okay, it is not that not like you need to always find average for the initial and final point. You can find average between any two intervals. I want to find average between these 2 points, just join them, this is the displacement, and find the time. Okay, is it okay? Okay, so average thing is not valid only for initial and final point, it is valid for any 2 points, any 2 times. Okay, okay. Now the next thing would be instantaneous speed. Instantaneous speed, speed at that time, exact. Okay, so speed at that instant. Okay, and how to check it? You know, a vehicle has a speedometer which shows instantaneous speed. Is it okay? Is it okay? Now how to find it mathematically? Let's say this is the actual path. Let's say this is the actual path. So for small duration, let's say for small duration dt, this portion dx was covered. Okay, this portion dx was covered. So our instantaneous speed would be what? Dx by dt. Okay, it by default includes the condition that the time is very small, time duration is very small. Is it okay? Time duration is very small, dt is negligible. For instantaneous velocity, is there anything different? Is there anything different? If you want to find instantaneous velocity at this point, the displacement covered would be same. I would just be writing dx vector, ds or x interchangeably you can use. I would be writing dx vector only. So the instantaneous velocity would be dx vector by dt. Okay, apart from a vector sign it has no difference, which means what? Which means what? Since for very small portion the distance and displacement are same, instantaneous velocity and instantaneous speed would be same. Is it okay? The only difference would be of direction, otherwise magnitudes are same. Okay, one has direction, one doesn't have. Is it okay? So Can I erase? Now I have a question for you. This is of average actually. You do some questions of instantaneous. A car covers, a car, I'll write, a car covers first half distance with speed v1 and second half with speed v2. Find average speed. Some of you would actually be knowing it. Please don't spill the answer, let others find. Okay, I would be altering it as well. Okay, the original definition was total distance by total time. You should stick to it. Shortcut formulas are only applicable to a few cases. I'll show it to you right now in the next question. It doesn't matter. Speed or velocity are the same for a straight line motion. Okay, except that velocity doesn't have any direction. Speed doesn't have any direction. That's it. Somebody said something. Minus s distance covered with speed v1. S distance covered with speed v2. Okay. The problem is I don't have time. I don't have time वैसे भी, but I don't have time for these portions. So the time first would be s by v1. For second it would be s by v2. I don't know s actually. It was not mentioned. I assumed it. The first portion has s distance, second portion has s distance. So the average speed would be how much? Total distance is 2s, total time is t1 plus t2. I don't know s, I don't know t1, I don't know t2. Again 2s by s upon v1 plus s upon v2. Okay, take s common, 1 by v1 plus 1 by v2. And s cancels up and down. You can take LCM. It would become v2 plus v1 upon v1 v2. So the answer is 2 v1 v2 upon v1 plus v2. Okay. This is a formula actually, can be used when the whole distance is divided into two parts, just two parts. Don't use it for 3, 4, 5 parts. You would get wrong answers. Is it okay? What people do is they extend it for 3 parts. If I divide it into 3 parts, what they would do? They would write 3 v1 v2 v3 upon v1 plus v2 plus v3. Wrong. Dimensionally incorrect. Okay. So don't extend it for 3 parts. Solve for 3 parts. Approach is similar if 3 parts are given. So the applicable case is what? Let's say you go to a market at a speed of 40 km per hour and you come back at a speed of 60 km per hour. While going to the market, in fact it should be reverse. This is 60 and this is 40. We are always excited when we go to market actually. So that's why. So in this scenario, since both the portions have equal distance, the answer is 2 into 60 into 40 upon 60 plus 40. You can find the answer, it would be 48. Okay. Now in this scenario, the questions they ask, what is the average velocity? Is 0, displacement 0. Okay. So this was groundwork. This is not the actual question. I just wanted to discuss this so that I can discuss the next concept. The concept is this. The next question. The question is this. Let's start. a car moves in such a manner that it covers first half distance, with speed v naught, but for second half distance it travels with speed v1 and v2. Just a second. It travels with speed v1 and v2 for equal times. Find average speed. Getting my point? First we divided the distance into two parts. The first part is covered with speed v naught. Then what we did, out of second part we divided time into two parts. Okay, now let's find. You are given 2-3 minutes. We cannot spare more than this. I'll draw the diagram actually. Okay, motion diagram. This portion S is covered with a speed v naught, and for this portion we have time t. Here the speed was v1 and here it was v2. This is again S, but okay. So let's see if anyone finds it. And I am expecting some answers from people online, students online. Okay. No. In the second half, whatever the time is taken, half of it is covered. Half of the time is, the speed is v1. The car travels with v1, and for this later half, it travels with v2. So the distances are not equal. It is just that v1t plus v2t, they would add up to form S. Okay, not each part is S by 2. I guess we have I think it is partially correct, but still great attempt. Let's it's not completely correct, I'm sorry. Yes, please. कुछ आया आंसर? Can I see?
सर अभी p की हम और वैल्यू सब्स्टिट्यूट कर
नहीं कर पाओगे. और कैसे फाइंड करोगे? You don't have any further equations, right? So now let's see. नहीं, ये तो ऊपर नीचे की चीज सेम हो गई. Let's check क्या आंसर होगा. Now what you need to understand here is the concept of equivalence. What is equivalent thing? Equivalent resistance. Do you remember equivalent resistance? Do you remember equivalent resistance? क्या था? Equivalent resistance was a single resistance that created same effect. Okay. Now here, instead of these two velocities, can we not put equivalent velocity? कर सकते हैं हम. Same distance, same time में ही तो travel करना है. We need to travel same distance in same time. So for this portion only, don't focus on that one. For this portion only, the average is how much? For this portion, the distance traveled is v1t plus v2t and the time taken is 2t, right? So for this portion, average is this, let's call it VAV1 dash. Okay, this is v1 plus v2 by 2. So what I mean to say is, instead of traveling like this, if I traveled with a speed of v0 in this portion and v1 plus v2 by 2 in the second portion, I would have covered the same distance in same time. Is it okay? Average means what? Getting the same effect in same time. Is it okay? So if by instead of doing this, I traveled whole of the second part with this velocity, average velocity, I would have covered same distance s and in same time 2t. Is it okay? I would have covered same distance s in same time 2t. Is it okay? So this is what? V average 1. Yeah, V average dash. Okay. Now we have reduced the scenario of 3 velocities into 2, and we already knew what to do with 2. We have equal distance covered with different velocities. This is similar to the previous case. Is it okay? So now the average would become V0 V average dash, sorry, 2 V0 V average dash upon 2 V0, sorry, this is V0 plus V average dash, 2 V1 V2 upon V1 plus V2. Okay, replace the values, you get 2 V0 V1 plus V2 by 2 upon V0 plus V1 plus V2 by 2. Okay, कुछ आंसर आ जाएगा? This is the answer. Okay, and people were writing V were 2 V0 V1 V2 all multiplied. Okay, I would be repeating it. Now check, we had 3 parts, okay, 2 major parts, and out of 1 major part we made 2 small parts. Okay, okay, we divided it in this manner, 1 big part, so 2 parts, and out of this 1 part, second part, we made 2 sub parts. What if we do the reverse way? Okay, if we pick these 2 sub parts and form a big part out of it, and then pick these 2 big parts and form a bigger part, is it okay? That's what I did. In this second portion, well, when I am considering second portion, I am neglecting this. The problem here is, if I continue seeing this portion, the left half, I will not be able to understand the right portion clearly. So For the second half only, let's find the average. It's not that difficult. The for first t time distance travelled is v1 into t. For second t time the distance travelled is v2 into t. When times are equal, the speed, the average speed is always v1 plus v2 by 2. When times are equal. This was taught to you in 9th class. Okay, so that's why I didn't discuss it. Now replace this thing into the original scenario. In the original scenario, first half was covered with a speed of v0 and the second half was covered with a speed of v average dash. V average dash is this. Is it okay? Is it okay? Instead of having two different velocities at two different times, I am using one single velocity which would create the same effect in the same time. Clear hai? Is it okay? So I replaced this thing instead of these two portions here. So now we have two velocities for equal distances. We already knew the formula 2 v1 v2 by v1 plus v2. Okay, replacing it. Now you understand, you can do it for different scenarios as well. Okay, okay, we can have further subdivision, a different kind of arrangement. Is it okay? But the way to do would again be same. How? Again approach, pick the smallest parts, combine them, form a bigger part, then pick two big parts, combine them, form a bigger part, and so on. That's what I did. Is it okay? Can we continue? Okay. Now this was an XJE question actually. That's why it was a little difficult. Okay. IIT-JEE question. I don't remember the year, but it came in IIT-JEE. Now, I just would like to ask, what is the direction of instantaneous velocity? This is the path here. What is the direction of instantaneous velocity? Direction, I said. For this small portion, this is the direction of displacement. Okay. So the instantaneous velocity would have direction along this, which is what? Tangential. Okay. So instantaneous velocity has tangential direction, and that's why in uniform circular motion we always say that velocity is tangent to the circle. Is it okay? So I'll erase this. I thought that you would know this. Okay. Direction of instantaneous velocity is tangential to the path. Is it okay? So even though we are studying straight line motion, these basic quantities would be covered in a bigger manner. We would be discussing the basic quantities for 2D and 3D motion as well. Sorry. Now average acceleration, you already know. Change in velocity on time, quantime, is it okay? And instantaneous, yes, dv vector upon dt. Direction of this would be along which? Direction is along v2 vector minus v1 vector. People make a mistake. They never they find the direction always along final velocity. Okay, the direction would always be along difference. We would see it in a question. Instantaneous, what would be the direction in this case? In this case you need to find actually. So for example, for circular motion it is along along radius towards center. Instantaneous acceleration is towards center. Okay, so in those scenarios you need to find actually For instantaneous you need to find, but for average it is along V2 minus V1. Now let's check it in the form of a question. A car turns with speed of 5 meter per second east to 5 meter per second north in from east to north in 10 seconds. Average acceleration is the first option is 1 by root 2 meter per second square northeast, 1 by root 2 meter per second square northwest, 1 by root 2 meter per second square southeast, and 1 by root 2 meter per second square southwest. So you see the values are same, only the directions are different. Find the direction. I just wanted to discuss one more thing. This can also be written as this. If I remove the vector signs, it looks like this. V dv by dx. Okay, I'm removing the vector signs so that you don't get confused. Okay, this is a very useful form. We'll see what to make out of it. ये पता है सबको? All of you know about this form? हाँ? नहीं पता? Okay, let's check. This was dv by dt. Multiply and divide with the dx. Okay, so this is dv by dt into dx by dx. Okay, swap. What you get? dv by dx into dx by dt. This thing is v. You get v dv by dx. A useful form. What is the answer in this case? The car was moving towards east, then it turned north. Okay, it turned north in 10 seconds. The direction would be कुछ हुआ? Why am I getting this idea that actually I am teaching something tough? Is it tough? Yes? Then you need to study a lot. It's the basics. Exactly. Second option. First बहुत लोग बोलते हैं. That's why I gave it the first. What people do, this is V1, this is V2, they join it here and they say, okay, this is the change in velocity. So direction of acceleration should be like this. Now let me tell you, these two are in order. So this is what? The resultant, not difference, not difference. Okay, okay. So in vectors it would have been taught to you how to calculate vector difference. Or don't you remember? Do you remember or do you not? Whenever you have two vectors placed like this, not exactly like this, it can be anything like this. If you want to find the difference, you know, whenever I give this kind of arrangement, by default somehow people jump to this thing and they say this is the difference. How come this is the difference? The first vector and the second vector are in order, and whenever two vectors are in order, the completing side is always the resultant. Exactly. So what would be the difference? How to find the difference? One sure short clear way: place the two vectors, these are the two vectors, place the two vectors tail to tail. Okay, I am not a very big fan of triangle law. Why? The problem is, for difference it is useless, you make mistakes. So I am a very big fan of parallelogram law, because for the same parallelogram you get you get sum as well as difference. So now make, place them tail to tail. This is A vector, this is B. Let's say you need to find A minus B. You would get A vector plus of minus B vector. Getting my point? This is what? Negative B vector. So let's do a negative B. Let's draw a negative B. The negative B is like this. You need to find a resultant of A and negative B. So the resultant of A and negative B is this kind of vector. Is this kind of vector? Is it okay? Is it okay? That difficult? Is it that difficult? Very easy. Okay. But somehow you understand this and you don't understand this. Let's check what mistake you did. This is the first vector V1. This is the second vector V2. If you join this, it would be resultant. Draw them tail to tail. This is the tail to tail thing, V1, V2. You need V2 vector minus V1 vector, okay, which is actually as good as V2 vector plus of minus V1 vector. Is it okay? What this means? Negative V1, swap it. This is minus V1. So the result, the parallelogram would be like this. The parallelogram would be like this, and this is the resultant. The resultant of V2 and minus V1. Is it okay? The resultant of V2 and minus V1, that means the difference vector. The difference vector is in which direction? Northwest. Since V2 minus V1 is in northwest direction, acceleration would be in northwest direction. Okay. I didn't ask you to find the magnitude because it is the simplest thing to find. This is 5, this is 5. The diagonal would be 5 root 2. The time taken is 10 seconds. The change in velocity is 5 root 2 and time taken is 10 seconds. So V2 minus V1 upon T, which would be 5 root 2 upon 10, 1 by root 2, straightforward. Okay. The value is straightforward to find, but the mistake people do is with the direction. I hope this would remain in your heads for some time at least. Okay. This is not a mistake that you only did. This is a very classical mistake. I somehow convince my students into making this mistake. Every time this happens, I tell them the direction is along V2 minus V1, and every time they do the same thing when they solve. This is a sequence. I use same sequence in my class and they do the same mistakes as you. So let's continue. Okay, I'll erase this one. Somebody is asking some question. Repeat the same question again. Okay. I'll erase the rest of it. You need to find average acceleration, okay, which was V2 vector minus V1 vector, change in velocity upon time. The direction of this vector would be along the difference. Okay. Now how to find the difference? The first vector is along this, the second vector is along this. East and then north, they have same magnitude, 5 meter per second, 5 meter per second, turns with speed 5 meter per second. So the car maintains its speed, it is just that it is changing the direction. Okay. Since it is changing the direction, there would be non-zero acceleration. Okay, whenever there is change in velocity, there is some acceleration, and velocity can be changed by changing its magnitude or by changing its direction. Is it okay? Is it okay? Clear hai? So now let's check. For finding the difference, what people do, they make a mistake that actually they go ahead and join this. Classical mistake. This way you would be able to find the sum, not the difference. Is it okay? Never join this. Now for finding the difference, what we do, the process that we follow is drawing them tail to tail. As you know that a vector can be shifted parallel to itself. A vector can be shifted parallel to itself. I will draw it here actually, lack of space up there. So this is the first vector v2, sorry, this is the first vector v1, this is the other vector v2. Okay, tail to tail, you know, I shift it forward here, I draw it here. Okay, so you need to find v2 minus v1, and I can always write it as what, v2 plus of minus v1, which means what, I am finding sum of v2 and minus v1. So I am trying to find sum of v2 and minus v1. So to find this sum, we first need to find minus v1. Minus v1 would be this. Reverse. Do you know negative of a vector is what? Vector with same magnitude but opposite direction. This is negative vector. Okay. You need to add them up. So adding them up is via this, the parallelogram law. Is it right? ठीक है. This is the resultant. Okay, resultant of what? v2 and minus v1, or the difference vector. This is the difference vector. It is directed along northwest direction. ठीक है. Okay, so I hope this time it's clear. I'll erase this. We'll continue. Now let's find a relation between instantaneous quantities. Obviously distance and displacement are not instantaneous quantities, but they would be a part of this topic. Okay, distance and displacement are not instantaneous quantities, but they would be a part of this topic. Now do you remember this, that actually instantaneous velocity is slope or something? I'll explain it, don't worry. I would just ask one thing. What do you know about integration? What do you know about differentiation?
Integration, we need the summation, like different parts we need to join together and see them as a whole unit. And differentiation is breaking into different parts.
Exactly. So precise definition. Differentiation is what? Breaking the whole thing, breaking a big quantity into small chunks. Example, you have your 24-hour day. Okay, breaking it into hours, into minutes, seconds is differentiation. Okay, okay. Now integration is what? Reverse, adding up. Okay, whenever I say dx by dt, I am trying to find the rate. Okay, I am splitting x into small parts, I am splitting time into small parts. I am trying to find for this small amount of time what was the change in x. Is it okay? The ratio, the rate. So I asked this because you know in this topic we would be discussing some things related to differentiation and integration, basic nature. Okay, so you know that integration, that whenever I say, let's say we have this graph y versus x. Whenever I say dy by dx, it is what? Slope of tangent. Do you know it? क्या ये पता है? कुछ लोगों को पता है, I guess. कुछ लोगों को नहीं पता है. As far as I can see, and the same would be the scenario for online people. So first let's discuss physical meaning of differentiation and integration. Then we would be able to actually learn the relation. So I'll erase it. physical meaning of derivative, then we would be doing physical meaning of integration, and then actually we would be able to learn the relation. Now let's say this is a y versus x graph. Do you know something about functions? Some functions, a lot of mathematical terms, but I hope that you know functions. नहीं, whenever I write y is equal to fx, what does it mean? किसी को पता है? X, y is a function of x. What actually it means? It simply means that y is dependent only on x. When x changes, y changes, but when z changes, पता नहीं, x के ऊपर कोई, y के ऊपर कोई इफेक्ट नहीं होगा. When z changes, y doesn't change. Is it okay? 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 So function is some basic rule in which when you change x, y changes. So function basic thing is, it is kind of a machine. You input x, you get output y. Only x is the input and only y is the output. Is it okay? So any kind of thing, any kind of dependence that you see in the world, you can write it in the form of mathematical function. Let's take examples. Okay, you work hard in the morning, exercise. You exercise hard in the morning and you eat a lot of breakfast. So amount of breakfast is dependent on amount of exercise. Can I say that breakfast is a function of exercise? Straight away. Okay, so it's not a very hoo-ha difficult kind of stuff. It is very simple. Okay, okay, technical stuff. You know, the fuel consumed by an airplane is directly proportional, is dependent on its speed. So can I say fuel is a function of speed? I don't know what is the background rule, but I just know that fuel is a function of speed. So that background rule is the expression, okay, mathematical expression. So whenever I say y is equal to x square plus 2x plus 1, okay, I say y is a quadratic function of x power 2. Y is e raised to power x, y is an exponential function of x. Is it okay? You getting my point? So it is not the background rule that is important to us, it is the relation that is important, that y depends on x and so on. Is it okay? Can I erase this? I just wanted to give you a brief overview of what a function is, because here we will see a lot many functions. So physical meaning of derivative. Let's say the graph of a function y is a function of x. What happens when x increases, y increases? Okay, initially it increases slowly, but then it increases very rapidly. Some sort of function, I don't know what type. Okay, I want to find the change. So I have this point, starting point A, I have this final point B. If I want to find the change between these two, what I would do, I would draw a line. Okay, let's draw perpendiculars. I'll shorten it slightly. Okay, let's draw perpendiculars. This is x1, this is y1, this is x2, this is y2. Is it okay? Is it okay? Now for A, from A to B, the change in y is how much? The change in y is just this much. Okay, I call it delta y, it is y2 minus y1. Similarly, if I find delta x, change in x is this much, x2 minus x1. Okay, if I try to find the rate of change, okay, you are trying to find the rate of change. So the rate of change would be y2 minus y1, x2 minus x1. What does rate of change means? Rate of change means how one quantity changes when first quantity is changed by one value. Okay, how y changes when x changes by 1, that is rate of change. Okay, when x there is change in x, change in value of x by 1. What is the change in y? Is it okay? Can we go forward? So now in this scenario, what we are doing, we are not actually looking at what is happening in between. We are concerned with the initial and the final values. Okay, had the graph been like this, it would have been okay. Final result मुझे उतना ही मिलता है, right? So it's in the real world. In the real world, it's this kind of scenario. You have a startup. You start. You one day you would graduate from IIT and in IIT and you would like to have a startup. Okay. So now you start a startup. Okay. Initially, you asked someone to invest some money. They put 100 crores in your company. Okay. After some time, the 100 crores reduces to 50. You lost 50 crore in running the company, but eventually things start picking up and this 50 crore becomes 500 crore. So that guy would be, let's say that this thing happens in 5 years. So in 5 years, you started from 100 and reached to 500. The profit per year would be 400 crore by 5, which means 80 crore. This guy, the investor, he comes back after 5 years and asks, kya profit hai boss? You show, here is your money. Okay, big bag, huge bag. Is it okay? Now this guy, this reckless kind of guy, I would not do this kind of thing with my money actually. So this guy does this kind of stuff. Is it okay? He comes back after 5 years and checks the records and finds 80 crore per year profit. He doesn't know the actual picture. Okay, he doesn't know that actually for the first 6 months you lost 50 crore. So there is one other kind of investor who regularly checks. Okay, who wants to get the detail of all those 5 years. So every day he comes and he checks kya ho raha hai, or maybe every month. So he would see that actually internally कुछ तो झोल झाल है, कुछ तो गड़बड़ हुआ बीच में. But okay, तो क्या होता? That normal guy would have pulled money 50 crore out of the company and left. नहीं और नहीं झेल सकते, जितना बचा है let's take it home. Okay, but this our guy was very confident. He came back only after 5 years. So whenever you have this big kind of scenario, huge interval, if you find rate, it is what? It is like an overview of whole thing. Okay, you went to see the movie MS Dhoni. You knew your friend comes back. Okay, after the movie, he says, okay, this Dhoni guy was a ticket collector, then finally he became a star batsman. Long story short, our thing, this rate, you go to movie and you try to find what exactly happened the other way, every part, every detail. So let's find the difference, why this thing and that small part, every bit matters. This thing, for whole this period, this thing is called average rate. This thing is called average rate. Okay, so you are trying to find what happened for whole of the interval. You are not concerned what happened in between. So average profit was 80 crore. Okay, the other thing is called instantaneous rate. The other thing is called instantaneous rate, which would be what? Now start bringing B closer. It comes here, the line changes. By the way, this line AB is called a chord. What is a chord? A chord is any line which joins 2 points on the curve. So it is not valid only for circles, it is valid for all type of curves. It is slope of chord. Instantaneous rate, you try to bring it closer and you bring it this close. The 2 points are now almost overlapping. Is it okay? So in between these 2 points there would be very tiny gap. So whenever we use this kind of condition, we say it is instantaneous rate because the things are happening for a very short interval. Okay, so it is with this condition that the change in x, the change in x is this thing, very small change in x. The change in x should be very small, negligible. So we give this condition delta x tends to 0. This is limit. Okay, limit delta x tends to 0. We read it like this: limit delta x tends to 0. It means that the change in x is negligible, very small. And when we try to find this thing, we get what? dy by dx, derivative, you already know. So if you try to find, if you draw the chord would be like this. For very close points, the chord, the curve and the tangent, they are overlapping, they are almost same. I'll redraw. This was the curve, these are the 2 points. The chord is this, the curve is this, and the tangent would be this. Okay, so for these, for 2 very near points, the chord, the tangent and the curve are same. So whenever we say instant rate, we try to find slope of tangent. Okay, we find slope of tangent. Is it okay? Okay, this is the physical meaning of derivative. Whenever I say rate of change of something, which means if we draw a graph, that rate would be what? Slope of tangent. Okay, you need to mention the point, because at different points the tangents would be different. So whether you need tangent at x equal to 1 or you need a tangent at x equal to 5, you need to mention that. Is it okay? So average rate needs 2 quantities, initial and final, and instantaneous rate needs 1 quantity only, that is the time at which you need to draw tangent. Is it okay? Can I erase this? You understood the difference, chord and tangent? Okay, I will erase this. Okay, we spent a lot of time in this. Now, physical meaning of integration. Now, as somebody said, what is integration? Summation. Okay. Now, let's say this is the graph given. This is the graph given. Okay. You need to find the area under it. Okay. We know area of a rectangle, of a triangle, of a circle, but this kind of graph, how to deal with it? Let's divide. Let's say we need to find the area from here to here. These are the 2 points, x1 to x2. Let's divide this area into thin strips. These are not thin, but actually I cannot divide it into very thin strips. Okay, let's divide this area into very thin strips. Since when every strip is very thin, it can be treated like a rectangle. If y is the length and dx is the thickness, the area of rectangle would be, area of strip would be y dx. Okay. If we want to find the area, what we would do? We would find the area of all these strips and add. So area, total area would be what? Total area would be y1 dx1, then y2 dx2, and so on. The areas of all the strips. Now, since every strip is really thin, there would be a large number of strips. We cannot actually add them. Okay. So what we do is we find a different way of adding. You know, one way of adding is summation. Summation, do you know this sign? Summation I to n, something n or something, n plus 1. Sequence series में पढ़ लिया होगा अभी तक. Okay. So one way of doing it is summation. But there is a problem with summation. Summation can handle only limited values. These are very large number of values. So we find another way. We start using this integration. Okay. So what is integration? The physical meaning of integration is the area under the curve. Okay. Area under the curve y is equal to fx. Y is a function of x. I plotted it on the graph. Okay. I plotted it on the graph, and if I want to find the area, I'll integrate it. Now, x1 and x2 is the portion out of which we need to find the area. So these x1 and x2, they are placed at top and bottom. These are called the limits. Okay, so when no limit is mentioned, we find the area from 0 to x. Let's say this is the curve. So 0 to x, all this area would be covered if no limits are put. If limits are put, then we would find the area from for this mentioned portion only. Is it okay? Is it okay? So this is the physical meaning of integration. Now let's come back to our syllabus. Can I erase? Enough of maths? Okay. See, I'm sorry I had to run through because this thing takes a little time actually to get used to understand properly. But since while we spend time on this, we are losing time on our topic actually. That's why I had to rush through. So we were doing relation between instantaneous quantities. So let's start. This is displacement s, okay, velocity v, acceleration a. You differentiate it, you get velocity, you differentiate it, you get acceleration. Okay, you integrate it. Now let's find integration. We already understood what differentiation means. We didn't do integration kind of stuff. So you know a is dv by dt. Is it okay? dv would be a dt integrated. Initial velocity v1, final velocity v2. Initial time t1, final time t2. So this thing would become v2 minus v1, which is integral a dt t1 to t2. So actually integration of a gives change in velocity, not velocity, it gives change in velocity. So integral a dt gives v2 minus v1, not exactly velocity, but if initial velocity is 0, then you can find final velocity. Is it okay? From here to here, integral v dt gives s. How? V is ds by dt, you get ds as v dt integrated. Okay, initially generally displacement is given as 0, final displacement would be s. So this would be v dt integral time t1 to t2. S is what? Integral t1 to t2 v dt, like this. Okay, this is the mathematical interpretation. Let's have graphical. This is slope of st curve. Derivative means slope. Is it okay? Derivative means slope. So this is slope of displacement time graph. Here it means slope of what? Velocity time. बिल्कुल सही. vt curve. Okay. Can I erase this? ये आप लोगों को ऑलरेडी पता होगा. 3 इक्वेशंस ऑफ मोशन करते टाइम ये किया होगा ना. So I'll erase this. I'll write here. Change in velocity is actually equal to area under at curve. Whenever I say integration, it is what? Area under curve. Okay, but area under curve gives change in velocity. I am explicitly writing here. Displacement is what? Area under st curve. Okay, is it okay? Now write this down, and I'll give a short one important thing also. I'll write here a small note. Sorry, I accidentally wrote it. Thank you for correcting. I hope it is okay. Can I erase? People are writing still. Now the note I'll write on the top. Note. This note applies only to integration. Can I at least erase here? No space actually. I'm sorry. Those who are writing the right portion can write. Continue. Note. See, what if the graph has some portion above and some portion below? What if the graph has some portion above and some portion below? If the VT curve, note, if VT curve has some negative portion, how do we treat it? We call it positive area, A1. We call it negative area, A2. What does this positive area means? It means positive displacement. Here it means negative displacement. So if we want to find the total displacement, what we would do? We would subtract. Okay. So in this kind of scenario, net displacement would be what? Positive displacement, positive area, okay, A1 minus A2. Positive displacement minus negative displacement. What about distance? Since distance is never subtracted, it always adds. Distance में क्या होगा? They would be added. Getting my point? Positive displacement and negative displacement were there. So positive displacement is negative displacement is subtracted from positive displacement, right? Subtraction. But for total distance, since distance is always positive, it would be A1 plus A2. Please keep this in mind. Okay. Okay. For negative area, we take subtraction, but when we find distance, we add even that one also. We add even the negative area as well. Okay. So if you are okay, we can start. Next. ठीक है. A lot of stuff has to be covered actually. Okay, we are running behind the schedule because of, okay, the time's up. We are running behind the schedule, and you know why? I had to teach the calculus, integration, differentiation, which you should have known. Okay. So start having this habit of coming after you have done your NCRT. Is it okay? Okay. If you come here blank, frankly, after 1 or 1.5 years, you would still be blank. The problem here is that we run fast. The time is limited, so we had to run fast. We have to run fast. It is not with me, it is with all the teachers. So at least have your basics ready. If I had not spent a lot of time on basics, we would have completed whatever was designated for today. So I would have to finish it in the later portion, in the next class maybe. Is it okay? So, bye-bye for now. Okay, study hard.